I get to bring to you today two things that I'm very passionate about, and that is not only technology, which is what my entire channel is based off of, and how we can use technology in the classroom, but also math. Today I'm going to give you, hopefully, a multi-tool that you will use with your students daily that will help improve multiplication, division, equivalent fractions, reducing fractions, greatest common factor, and least common multiple, understanding all of those all at once. Let me explain what it is and how to get to this multi-tool that I'm giving to you for free. It's just jump counting. And in order to go to it, if you can go to my website at parksandeducation.com, scroll down, and you're going to see right here the jump count, and what I call the greatest mathematical teaching tool. And it's because of everything that I just told you. When you click on this, you're going to be able to open up a Google Sheet, and students are able to make a copy of it. When it opens, this is what they see. And if you scroll down just a little bit, you'll see that there's 20s and 25s. I'll talk about those in just a bit. But really, in my 7th grade classroom, I wanted them to master jump counting from 1s to 15s up to the multiple of 10. So we would do this by paper every single day as their bell ringer or ticket in the door, and there was just a couple of minutes, usually about 5, on the clock as it counted down, and that's how we would start class every single day. I would collect them, we would start our lesson, they would leave. I would take a quick look at them, see what they did correct or incorrect, and try to reteach the following day. And reteach strategies also, because when students start to fill this out, they're going to start with the numbers that they really understand, right? What the patterns that I saw was students would do 1s, 2s, they would do 5s, they would do 10s. After I showed them a little bit, they would do 11s really quickly. And then we had to find strategies for other numbers. So let me start to fill this out as a student might and show you some strategies along the way. The one thing that you're going to notice as you start to fill this out is that if you are correct, when you fill in the box, it will turn a shade of green all the way up to 10 there. If for some reason you go along and you don't fill out one correctly, you now have instant feedback. If the number isn't correct, it will turn red, letting students know that they've done something wrong. And they're able to fix their mistake quickly and right away. And this is going to help with their repetition. And this repetition is going to stress the positive of how to jump count by a particular number correctly. We've got 2 different color shades of green, and I'll show you why I did that as well. It's going to help with equivalent fractions and also reducing fractions. Now, I did the 3s kind of out of order. Not like a student probably would. Students would probably first time go to the 5s next, because, especially after 2s, because they're really simple to count by. I always say the 1s, even the 2s, the 5s, the 10s, why do students go there first? You can ask this question maybe in your class if you haven't thought about it, but the correct answer is money, right? I always say if we had a $3 bill or if we had a $7 bill, don't you think we'd be better at counting by 3s and 7s right from the beginning? We have a $10 bill, we have a $1 bill, we have a $5 bill, we even have a $2 bill. It's rare, but we have it. So typically students may fill this out first, and as they get used to it, this is the part where they feel comfortable. And so I make sure to let them know that it's not just left to right, but also column-wise, top to bottom. If we stay here and you start going down in this column of 2s, 2, 4, 6, we can start filling in some gaps. 8, 10, 12, 14, 16, 18, 20, and so on, all the way down to 15. Okay? You can do that with also your 5s, if they're strong with those. And this is going to help as they start to fill in other numbers, some of those gaps in understanding, okay, how far away are we? And what do we actually have to add to the previous number in order to get the correct number? So we filled in quite a bit. Now, as I go along, I'm going to do 4s. We can do 4, 8, and then we just add 4 more from the previous number. So 4 more is 12, 4 more is 16, 4 more is 20, which I already have. 20 plus 4 is 24, plus 4 more is 28, and 4s start to become easier when we can picture what the next number is going to be in our head. 6s, 7s, 8s, and 9s, those can be a struggle. So let's skip them for a minute and let's go down to 11s. And 11s are going to be the same thing as 1s, except it's going to just be double the number. You can see it here at 22 and 55. So when we get to 3s, it's not 3, but it's 33 and 44 and then 55. So students right away will catch on to that, and that will become one of those numbers that they complete, one row of numbers that they complete right away. Going back to the 6s, if we just add 6 more to 12, we get 18, and then kind of in between 18 and 30, we get 24. 30 plus 6 is very easy, 36, 42, 6 more is 48, and then this one can be a little bit tough, but 54, and then 60. And again, any mistake that you make, some kids may put 56 here, it's going to give them that instant feedback, and they know that they are incorrect. So they have to go back and change it. Okay, I'm going to go down and show you one strategy for the 12s, 13s, 14s, and even the 15s. 13s or 14s tend to be the one that give students the most trouble. And so what I do is I tell students, let's break this into 2 different addition problems from the previous number. I'm going to link in the description below a Chrome extension that is very useful. And one of the reasons I made this side a dark blue is so that we could use this tool as we're doing our jump counting. Students have touchscreen Chromebooks. Even with a mouse that I'm going to use here, I'm going to use the paint tool. And I have my color set to white. I'm going to click on the pencil here, and I see that I have the number 26. Well, if I have the number 13, a number bond is a multi-tool, just like this is. And I know it's very easy for me to jump count by tens. And that means if I was going to go ahead and jump count by tens, I just have to add 3 more to be able to jump count by 13. So 26 plus 10 is going to give me 36, right? That's, for most students, they're going to catch on to jump counting by tens very easily. And then they just have to add 3 more. And that's going to give us a total of 39. And so now, I'm going to go back to my cursor. Now that I understand that concept, I can do 39 plus 10, which is 49, plus 3 more. Use your fingers if you have to. And we get 52. 65 was already there from our 5s, so 65 plus 10 more is 75. Plus 3 more is 78. And you can see how this strategy would work for 12s, just 10 plus 2 more, 14s, 10 plus 4 more, 15s, 10 plus 5 more. So I'm going to fast forward. I'm going to clear out what I've done already here with our paint tool, and I'm going to fill the rest of this in. We are completely filled out. And you can see how jump counting is going to help our multiplication skills. Making sure we understand how many times we have to jump count in order to solve the multiplication problem. So let's take the multiplication problem, 3 times 7. You can see 3 times 1 is here, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. Here's our answer to 3 times 7. 3 times 7 is 21. So if I have 3 times 7, the great part about this is we can slide, and that first column is locked. And so we can see right away that 3 times 7 is going to give us 21. So just like a typical multiplication chart that you may see in a classroom, and I don't see as many of these as I typically see just numbers that are counting up to 100 when I go into different elementary classrooms, I'd love to see more of the jump counting multiplication charts because students then are able to multiply and divide. So they're able to see 3 times 7. They're also able to see, if we scroll back, 7 times 3. So if I went this way, if I take 7 and 3 and I connect them, you can see a number bond is formed here. 7 times 3 is going to give us 21. So it's the same thing with division, right? If I want to do, let's say, 48 divided by 8, okay? Without sliding anything, and let me get this back so it's correct. Without sliding anything, we still can make our number bond. I'm going to find my 8. I'm going to circle that, and then I'm going to find 48. There it is. And I just go up, and I see that it's 6. And so 48 divided by 8 is 6. This is the great thing about number bonds as a multi-tool as well, is that you're getting 4 equations for the price of 1, if you think about it. We have 48 divided by 8. We have 48 divided by 6, right? We could know that. And then we also have the commutative property with multiplication. So we have 8 times 6, and we also have 6 times 8. So you're getting 4 for the price of 1. This jump counting tool not only is giving us instant feedback, but it is also a multi-tool in the fact that we are able to see the answers once we fill out this jump count to multiplication, division, all 4 of them, and then what I'm going to show you next, which is reducing fractions. Students have a tough time with that because it deals with some division, right? So let's take any fraction that you want. Let's start with 6/24. So really with a fraction, we have a numerator and a denominator, and all you need to know with our chart is that it needs to be in the same column. So the numerator and the denominator need to be in the same column. So if I find 6, that's right here, and I go down in this column, you're going to see that I see 24 right here. And you're also going to see 6 and 24 here as well. And so what you kind of need to understand is that, do you have a fraction that's completely reduced? The closer to the top that you can get your numerator, you know that you're going to have a completely reduced fraction. So since the 6 up here is at the top row and this one is 2 rows down, I'm going to use this row right here. And in order to reduce this, all I really need to do, I'm going to sweep this for a second. Here's my 6. All I need to do is pull it over. And now I can see exactly that 6/24 is equal to 1/4. It's pretty amazing if you think about it. Another way to do it without pulling it over, if students don't want to do that and they just want to use the pen tool, that's fine. You can take your 6 and just draw your line back with an arrow to what's at the beginning of its row. So 6/24 is equal to 1/4. Find any fraction that you want that's in the same column. The numbers are in the same column. The numerator, the denominator, they are all going to be in the same column. Look at one of your math sheets that you're going to give students right now. You can give them anything. So even 63, let's say 91sts. 63 91sts is going to reduce down to, I'm doing this with a mouse, so it's a little bit tough, but 9/13. Now, again, think about ones that maybe aren't completely reduced. So let me see if I can find a good example of this. Let's say we have something along the lines of 12/24. Now, I don't see 12. Oh, I do see it. 12/24 is up here. So that's a little bit higher up. And if we reduce this down, because we only jump counted to tens, you're not going to have everything we need to reduce. So 2/4. What we need to do now is take a look at 2/4, and can we find that on the board up top anywhere? And we can. 2/4 is right here, which can reduce down to 1/2. The more that students are able to see what they're able to reduce, the better that they're going to become at reducing. And it goes both ways. They're able to find equivalent fractions just as easily. If we have to find an equivalent fraction to 4/7, we've already done the hard work. We've already done the jump count. Now all we have to do is slide, and we can see that we have 8/14. And if we had to find something, let's say with a denominator of 35, you can see that 4/7 is the same thing as 20/35. And we can show that here, 4/7 is equal to 20/35. What did we multiply by in order to get this? We multiplied by 5. There's our number bond here and here. 7 times 5 and 4 times 5. Let's talk about least common multiple now. Least common multiple, greatest common factor are going to work and be part of this multi-tool up to a point, because we've only jump counted up to the multiples of 10, right? For each of the numbers 1 through 15. So if I have a question, the least common multiple of 8 and 5. What I want to do is I want to make sure that I find 8 and 5 on the side here, 5 and 8. And I'm going to look at each of these rows here, and I'm going to see if they have anything in common and what's the first thing that they have in common. Typically, it's going to be diagonal. And so if you notice, we've got 10 and 16. No, that's not going to work. 15 isn't going to work. 20. This is already at 24, 25 and 32, 30, that's not going to work. Look at this. I crossed it out just a little bit too early here. But you'll notice that when we get to 40, 40 is the first number that both of them are able to divide into. And so the least common multiple of 8 and 5 is going to be 40. Students are able to see it. They're able to visualize it. They're able to start to see patterns, and that's what we want. Here's another one. Let's find the least common multiple of 5, 10, and 3. So now we have 3 numbers that we're going to test out here. 3, 5, and 10. So we're going to start with 3, 5, and 10. And again, if you're working with a touchscreen Chromebook or something like that, this is going to be so much easier. Students use their finger, a stylus, whatever it is that they want. The thing that I know about tens is that counting by tens is going to be pretty even, right? And so 3, the only thing that I have that is multiplied by 10 is 30. So we're going to see if this is going to work out for us. 5 also has a 30, and 10 also has a 30. And so 30 is going to be the least common multiple for all 3 numbers of 3, 5, and 10. We're able to see it. Let's switch gears. Greatest common factor. So let's start greatest common factor with something along the lines of 6 and 15. That's the question that I'm pulling up right now. And so we want to find 6 and 15 somewhere in the same row. You could do column as well, but I just keep it as rows since we have it here. 6 and 15. The number 6 itself isn't going to be able to divide into 15, so we have to find both of those numbers in the same row. And I can see that right here I have a 6 and a 15 in the same row. So it looks to me that since they are in the same row, I just draw that line going back, that the greatest common factor between the two of them is going to be 3. What about one like the greatest common factor of 9 and 18? Now, I'm doing this on purpose because when we have 9 and 18, 9 is going to be the greatest common factor because it's in the same row as the number 18 right here. We can find 9 and 18 here as well. But again, for greatest common factor, we want to go as low as possible or as down on our number column as possible in order to find the greatest, the largest number that can be divided into both 9 and 18. So that's where we find that. I don't see 9 and 18 anywhere else on our chart. What about something like 3 and 17? 3 and 17. 3 isn't in this row here, and it's not going to be anywhere else. So the only thing that can go into both 3 and 17, and the largest number that can go into both, is just the number 1. So those are some of the things that you may come upon when doing least common multiple, greatest common factor. But hopefully you have an idea now of everything that I talked about: multiplication, division, finding equivalent fractions, reducing fractions, least common multiple, and greatest common factor. And then for an added bonus, I also added in at the very bottom, because I always worked with percents and students had to be able to jump count by 20s and 25s easily. So I put that in as a bonus. Students are able to go ahead and type that in as well. And once again, it will turn green. Let's say you make a mistake, it will turn red, just as the other boxes do as well. 25, and then our percents here to 50, 75%, and then 100%. Just understanding those, and it still holds true with our multiplication. If I zoom out just a little bit so that we can see it, that if I went ahead and did a number bond here and said, okay, 25, what's going to give me 75? I'm going to multiply it by 3. 25 times 3 is going to give me 75. 25 times 4 is going to give me 100. So the multiplication still holds true within our chart, even though we made a little bit of a jump there from 15 to 20 and then from 20 to 25. So please let me know if this is a tool that you think you're going to use in your classroom. Let me know in your comments if this is something that can make a difference in your room the way that it's done for my students, my regular yearly students, my 10 years of summer school experience with students. It's made such a difference in not only their mathematical skills, but the confidence that they have in math.